All right, let's dive into something pretty cool in the world of AI. We're going to talk about how an AI can learn a tricky new skill, not just by trying over and over, but by having its own internal coach.
So think about this for a second. How would an AI actually learn to do something physical, like balance a pole? It's not just about pushing left or right, it's about applying the perfect amount of force at the perfect time. This one simple sounding task actually shows us a massive challenge in AI.
And to really get why the solution is so clever, we first have to understand the problem they were up against. See, early AI was great at mastering games, but the real world? That was a whole different ballgame.
And this slide breaks it down perfectly. On one side, you have discrete actions. Think of a video game. You have a few clear choices: up, down, left, right. Simple. But the real world needs continuous actions. When you're balancing that pole, you have an infinite number of tiny, precise adjustments you could make. It's not just push, it's push with exactly zero point 0.3 newtons of force.
And this is exactly where the older methods just hit a wall. Algorithms like deep Q learning, which were absolute champions at games like Pac-Man, really stumbled when you asked them to do something that required that kind of precise, continuous control. It was clear a new playbook was needed.
So, how did the researchers get around this? Well, they totally flipped the script. Instead of just teaching an AI to figure out if it was in a good spot, they decided to teach it the best moves to make directly.
This new strategy is called a policy gradient. And really, it's like giving the AI a playbook or a policy. So instead of just looking at a chessboard and thinking, this is a good position, it learns a direct rule. When the board looks like this, the best move is that. This was a huge leap forward, and it's what allowed it to finally handle those tricky, continuous actions. But of course, there was a catch. This new method, all by itself, was kind of like a super talented athlete with no coach. The learning was all over the place, incredibly unstable. One minute, the AI's performance would be amazing, and the next, it was just awful. This wild inconsistency has a name, high variance, and it made getting reliable results a total nightmare.
And this right here brings us to the big breakthrough. To fix that instability, the researchers basically gave the player a coach. They split the AI into two parts, designed to work together as a team.
First up, you have the actor. Just think of this as the player on the field. This is the part of the AI that looks at the situation, makes a decision, and actually does something. It applies the force, it makes the move, it's the one doing all the work. And right there with it, you have the critic. Now, the critic is the coach. It doesn't actually do anything itself. It stays on the sidelines. Its only job is to watch the actor and give feedback, judging how good or bad every single move was. And what this creates is this really elegant feedback loop. The actor tries a move, the critic watches and basically says, for this situation, that was actually better than I expected. Or, nope, that was way worse. Then the actor takes that very specific feedback and uses it to update its playbook for next time. And this quote right here really hits the nail on the head. This is the secret sauce. The actor isn't just learning from some final score at the end of the game. It's getting targeted, moment-by-moment coaching. And that little piece of information, was my action better or worse than expected, is precisely what makes the whole learning process stable. Okay, so all this theory is great, but does this player-coach duo actually work in the real world? Well, let's put it to the test with a classic AI challenge, the inverted pendulum. The goal here sounds simple, but it is incredibly hard to pull off. You have to keep a pendulum balanced straight up. The thing is, the system is fundamentally unstable. Gravity is constantly trying to pull it down. The only way to win is to apply a perfectly controlled, continuous force at the base. It's the absolute perfect test for our actor-critic team. So at the very beginning, as you'd probably guess, our AI agent is completely clueless. Its actions are totally random and the pendulum just topples over instantly. Total failure. And we can actually put a number on that failure. Its starting score, or reward, is a dismal negative 1,500. That number basically reflects how badly it's doing. It's falling away from the goal and wasting a ton of energy. It's an F-. But then the coaching begins. Over the course of 300,000 practice runs, the actor makes its moves and the critic gives its feedback. They do this using a really solid modern algorithm called PPO, which helps make sure the actor doesn't make any crazy, wild changes to its strategy all at once. And the result? Just look at that. The average reward skyrockets from negative 1,500 all the way to negative 285. I mean, that is a massive, massive improvement. It proves the agent has actually learned the skill. It can keep the pendulum stable, minimizing mistakes and wasted effort. It mastered it. Now, this is about way more than just balancing a pendulum. This actor-critic framework is a foundational building block for some of the most advanced AI we have today. So why does this matter so much? Well, because this whole actor-critic idea is the bedrock for an entire family of really powerful algorithms. You've got A2C, DDPG, and of course PPO, the one we just saw in our example. These are the modern tools that are pushing the limits of what AI can do. Giving an AI a coach basically unlocked its ability to learn these incredibly complex physical tasks that used to be completely out of reach. This is how we train robots to walk, how we optimize massive supply chains and factories, and how we build AI that can make sophisticated decisions in the real world.
So this model, practice, paired with targeted feedback, has just completely changed the game for how AI learns. Which leaves us with a final, pretty exciting question. Now that AI has a coach to guide it, what huge real-world challenges is it going to master next?